So, let's go. Number 1, the worst prediction in the history of physics. Right now, all around you, the empty space between things is not empty. Reach out and grab a handful of nothing, a cube of pure vacuum with no atoms in it, and physics says that cube is quietly boiling, fields flickering in and out, tiny bursts of energy appearing and vanishing faster than anything can catch them. Empty space has a hum, an activity, an energy all its own, even when there is absolutely nothing in it. So physicists did the obvious thing. They calculated how much energy should be packed into that emptiness, and they used the best theory we have, the one that predicts the behavior of particles, so precisely, it's like measuring the distance across a whole country and getting it right down to the width of a single hair. That is how good this theory is. It does not miss. And then it missed. Not by a little. The calculation came back too big by a factor of 10, followed by 120 zeros. Let that sit for a second. When you measure how much energy is actually in empty space by watching how fast the universe is expanding, you get a small, gentle number. Something like the mass energy of a few atoms spread across an entire cubic meter. When you calculate what it should be, you get a number so enormous there is no comparison left in the physical world that even gets close. It is the single biggest gap between prediction and reality in the history of science. Physicists have an actual name for it. They call it the worst prediction ever made. And here's the part that should bother you. If the calculation were right, if space really held that much energy, the universe would have ripped itself apart in the first instant. No galaxies, no stars, no time to build a single atom. You would not be here to be confused by it, so something is holding that energy down. Canceling it out, not to 2 decimal places, not to 10, but to something like 120 decimal places of perfect precision. And nobody knows what does the canceling. Some physicists have quietly given up and suggested we simply live in one of the rare universes where the number came out small because we could never have existed in the ones where it didn't. That is not an answer. That is a shrug wearing a lab coat. We started with the emptiest thing in all of existence, and our best theory cannot explain it. It gets worse from here. Number 2, the particle that was caught wobbling wrong. There is a particle called the muon. Think of it as the electron's big cousin. Same kind of thing, but about 200 times heavier, and it only lives for a fraction of a second before it falls apart. And like the electron, it spins, which makes it act like a tiny magnet. Drop that tiny magnet into a strong magnetic field and it wobbles, the way a spinning top wobbles as it slows down. And the exact rate of that wobble is something physics can predict to staggering precision. So at a lab in Illinois, scientists built a ring, sent muons racing around it at nearly the speed of light, and watched them wobble. And in 2021, the wobble did not match the prediction. It was off. Just barely, but off. And in this world, a tiny mismatch like that is a scream. It meant something invisible was tugging on the muon, a force we had never cataloged, a particle hiding in the dark, reaching in and nudging the spin. For a few years, this was the most exciting crack in all of physics. Headlines everywhere. New physics, finally. The standard model, that rulebook that describes every particle we know, might actually be broken open. People got ready to rewrite the textbooks. Then reality did something sneakier than breaking. In 2025, that same team released the most precise measurement of the wobble ever made, pinned down to better than a few parts per billion. And at the same time, a separate group of scientists went back and recalculated what the muon should do using a different, more powerful method of predicting it, and the prediction moved. It slid right up to meet the measurement, the gap closed, the anomaly evaporated. The muon, it turns out, is behaving exactly the way the rules say it should. Except now there is a stranger problem underneath, because there are 2 different ways to calculate what the muon should do, and those 2 methods do not agree with each other. One way of predicting our own universe says one thing, the other way says something else. The particle is fine. It is our 2 versions of the rulebook that are quietly at war. Sit with that. We did not find a monster hiding in the dark. We found out that we cannot even agree on what our own theory predicts about a single, simple particle. That is a different kind of broken, and in some ways, it is worse than the monster. Number 3, the neutron, that won't agree on how long it lives. Pull a neutron out of an atom and set it free, and it dies. On its own, a lone neutron falls apart in about 15 minutes, decaying into a proton and a couple of other scraps. Simple. Predictable. You would think timing that would be the easiest thing in the world. There are 2 ways to do it. In the first, you trap a batch of ultra-cold neutrons in a bottle, wait a while, then count how many are left. Fewer survivors means they died faster. In the second, you fire a beam of neutrons through a chamber and count the little protons that appear as they decay. More protons means they died faster. 2 methods, same particle, same laws of physics. They should give the exact same answer, down to the last digit. They don't. The bottle says a neutron lives about 878 seconds. The beam says about 887 seconds. 9 seconds apart. And that gap has flatly refused to close for years, no matter how carefully anyone builds the experiment or checks the math. Now, here is where it turns strange. What if both methods are right? Look closely at what each one actually counts. The bottle counts every neutron that disappears for any reason at all. The beam only counts the ones that decay the normal way and spit out a proton you can catch. So what if a small slice of neutrons, maybe 1 in 100, are not dying the normal way? What if they are vanishing into something else entirely? Some physicists proposed exactly that back in 2018. The missing neutrons, they suggested, might be decaying into dark matter, slipping quietly out of our world. If that is true, it would be the first time we ever caught ordinary matter turning into the invisible stuff that outweighs everything we can see. A hidden doorway, tucked inside the most boring particle in the atom. So people went looking for the faint flash of light that kind of decay should leave behind. So far, nothing. Which means either the doorway is not there, or it is even quieter than anyone guessed. New experiments are being built right now in the United States and in Japan, specifically to settle which stopwatch is lying. Either way, 2 clocks are staring at the same dying particle and telling you 2 different times. And one of them might be watching it leave the universe. Number 4. The lithium. The Big Bang lost. Go back to the first 3 minutes of everything. The universe is a furnace, unimaginably hot, and cooling fast. And in those first minutes, the raw ingredients of the cosmos get forged out of pure energy. Hydrogen, helium, a tiny trace of a few other light elements. This is the recipe that built the very first atoms, and we understand it well enough to predict exactly how much of each ingredient should have come pouring out. And the recipe is stunningly, almost unreasonably good. It predicts the amount of hydrogen, and we go look, and it is right. It predicts the amount of one kind of helium, and it is right. It predicts a rare heavy form of hydrogen, and it nails that too. This is one of the great triumphs of all of science, a theory reaching back to the first 3 minutes of time and hitting the numbers dead on. Then you get to lithium. And the recipe says there should be a certain amount of it. So you go find the oldest stars in the galaxy, the ancient ones that still carry the original mix of elements from back then, and you measure their lithium. There's only about a third of what there should be. 2/3 of the universe's original lithium is simply missing. The same math that gets everything else right, the math that describes the birth of matter itself, whiffs completely on this one element. And nobody can agree why. Maybe the old stars quietly destroyed their own lithium over billions of years, dragging it down into their hot interiors where it burned away, so the stars we measure only look empty. Maybe there is a mistake buried in one of the nuclear reactions from those first minutes, a rate we have measured slightly wrong. Or maybe something we do not understand at all was happening back then, some new physics reaching in and stealing it. People have chased all 3 of these for decades, and here is the cruel part. Some of the improved calculations, the careful ones that were supposed to fix the problem, only made the gap bigger. So the theory that describes the opening moments of the entire universe, the one we trust for absolutely everything else, has a hole in it shaped exactly like a missing element. And the harder we look, the more stubborn that hole gets. Number 5, the first starlight that came back too cold. For the first few 100 million years, the universe had no stars at all, just cold, dark gas, drifting in the black. Then, Roughly 180 million years after the Big Bang, the first stars finally ignited, and their light spilled out into all that hydrogen for the very first time. And that first touch of starlight left a mark. A faint fingerprint buried in the radiostatic of the sky, a specific dip at a specific frequency that we can still detect today if our instruments are quiet enough to hear it. In 2018, a small antenna sitting in the Australian desert claimed to find it. A single dip down around 78 megahertz, the whisper from the cosmic dawn, the exact moment the lights came on across the universe. But the fingerprint was wrong. The dip was twice as deep as it was supposed to be. And the depth of that dip tells you directly how cold the gas was. Twice as deep means the gas was far, far colder than anything in standard physics can explain. The early universe, at that precise moment, was chilled below what the rules say is even possible. So what cools gas below the possible? One idea sent a real shiver through physics: dark matter. If the invisible stuff that outweighs everything we can see was quietly draining heat out of that hydrogen, actually touching it, that would explain the impossible cold. And it would be enormous, because we have never once caught dark matter interacting with normal matter through anything but gravity. Never. This would be the first handshake. The first time the invisible reached out and touched the visible, and we caught it happening. And then, the twist that keeps this one honest. A second experiment floating on a lake in India went looking for the exact same signal a few years later, and it did not find it. Not the deep dip, not a shallow one, nothing at all. It said the first antenna had probably been fooled, either by its own machinery or by the overwhelming roar of our own galaxy drowning the real sky out. So right now, we genuinely do not know. Did we hear dark matter touch the dawn of the universe, or did we hear a glitch in a radio in the desert? One of the single biggest possible discoveries in physics, balanced on a signal we cannot even confirm is real. Number 6. The hum underneath everything. Scattered across the galaxy are dead stars called pulsars. They spin hundreds of times every second, sweeping a beam of radio waves past us like the most reliable lighthouse in existence. So reliable, you could set your clock by them. Some of them keep better time than the atomic clocks we build here on Earth. Now imagine a wave rolling through space itself, not through the stuff in space, through space, a ripple in the fabric stretching and then squeezing the distance between us and a distant pulsar as it passes through. When that happens, the pulse arrives a hair early, then a hair late. We are talking a few billionths of a second, nothing you could ever notice on your own. Unless you watch dozens of these pulsars spread all across the sky for 15 straight years. Which is exactly what several teams around the world did, quietly, for over a decade. And in 2023, they all announced the same thing at almost the same moment. The pulses were shifting together in a very particular shared pattern that can only mean one thing. The entire galaxy is soaking in gravitational waves. A low, endless hum in the fabric of reality, with wavelengths measured in light years. A single ripple in this hum takes years to roll all the way past us. Think about what they actually did. They turned the whole Milky Way into a microphone. And it is picking up a sound. The obvious source is monster black holes. Pairs of them, each one billions of times the mass of the sun, slowly circling each other in the hearts of galaxies that long ago collided and merged. Their heavy, grinding orbits stir the fabric of space into this endless background swell. That is probably most of what we are hearing. But here's the catch. The hum came back a little louder than the black holes alone should be able to make, and that extra loudness leaves the door open to something far older and far stranger. Maybe some of that sound is not black holes at all. Maybe it is left over from the birth of the universe itself. Cracks in the early cosmos, echoes from the first fraction of a second, still ringing through everything, still rolling over you at this exact moment. You cannot feel it. You never will. But reality has a background noise, humming underneath all of it, and we only just learned how to hear it. Number 7. The whole sky is drifting the wrong way. Here's a rule that all of cosmology is built on. The universe, on the largest scales, looks the same in every direction. No special place, no preferred way to face. Turn all the way around, and it is the same everywhere. This idea is so fundamental that nearly every map of the cosmos we have ever drawn quietly assumes it is true. Pull that one rule out, and an enormous amount of what we believe falls down with it. There's a clever way to test it. As we move through the universe, the things ahead of us should bunch up slightly, look a little more crowded, the way rain on a windshield crowds toward the front of the car when you drive forward. So measure how the distant universe is crowded, in which direction things pile up. And you can figure out how fast and which way we are actually moving. So scientists counted. Over 1 million of the most distant objects we can see, the blazing bright cores of galaxies called quasars, scattered right across the whole sky. They measured the crowding, and they expected it to match the speed we already know we are traveling, a speed we can measure a completely different way, using the ancient light of the Big Bang. It did not match. The crowding was more than twice as strong as it should have been, as if we are moving far faster than we possibly are, or much more disturbingly, as if the universe genuinely is lopsided, with more stuff piled up in one direction than the other. When the result first came out, it was strong enough to look like a real break in the foundation. No, a cosmos with a preferred direction, after all. Now honesty, because this channel does not sell you a lie. More recent work has softened it, when you carefully account for the way quasars naturally clump together into little groups on their own. Some of that extra crowding washes out, and the mismatch shrinks. It did not vanish. It is still there, still nagging at people, just no longer the earthquake it first appeared to be. But think about what is even on the table here. One of the deepest assumptions we own, the idea that there is no special direction anywhere in the cosmos, is being openly questioned by nothing more exotic than counting the lights in the sky. And the sky is not fully cooperating with us. Number 8. The void we might be trapped inside. Look out far enough in every direction and something odd shows up. Our whole cosmic neighborhood, and it is a huge neighborhood, seems emptier than it should be. Fewer galaxies than average, spread across a bubble that might be 1 billion, light years wide, with us sitting somewhere near the middle of all that thinned out space. Scientists call it the local hole, a quiet, underpopulated region missing maybe 15 to 20% of the matter it ought to have, sitting inside an otherwise crowded universe. And that would just be a curiosity, except for what it quietly does to our measurements. Because there is a fight going on in cosmology right now, one of the biggest in the whole field. When you measure how fast the universe is expanding by looking at nearby galaxies, you get one number, around 73. When you measure that same expansion from the ancient light of the Big Bang, you get a different number, around 67. They do not match, and the mismatch has stubbornly refused to go away for years. But a bubble would explain it. If we really are sitting inside an emptier patch of space, then the galaxies around us get gently pulled outward, toward the denser walls of the bubble, the way water drains toward the edges of a shallow bowl. That extra outward pull would make everything nearby look like it is rushing away faster than the true universal rate. The whole famous disagreement would not be a crack in physics at all. It would be an illusion caused entirely by where we happen to be standing. And this is the moment the whole video quietly turns. Because up until now, each of these has been its own strange fact, its own isolated glitch. But step back and look at what keeps happening. Over and over, the real problem might not be that reality is broken. The real problem might be that we are measuring it from a broken vantage point. A weird spot, an empty bubble, the wrong seat in the theater. So which is it? Is the universe genuinely cracked, or are we simply standing in a strange place inside it, mistaking our own bad view for a broken cosmos? Hold on to that question hard, because from here on, it does not go away. It only gets sharper. Number 9, the twist in the oldest light. The oldest light in existence is still arriving right now. It set out almost 14 billion years ago, from the moment the universe first cooled enough to turn transparent, and it has been traveling toward us ever since without stopping. We see it as a faint glow filling the entire sky in every direction, the leftover afterglow of the Big Bang itself. And that light is gently polarized, which just means the waves are all oriented, tilted, in a particular direction, like light coming through a pair of sunglasses. Now here is the thing about that tilt. It should arrive exactly the way it left. The orientation of that ancient light should be untouched across the entire journey. 14 billion years of empty space and no good reason for the angle to change even slightly. But when scientists measured it very, very carefully, the tilt was off. Rotated. Just a fraction of a degree, a tiny twist, less than the width of the full moon in the sky, as if something, spread through all of space along the entire path, had reached in and slowly turned the light as it flew toward us. And there is really only one clean way that happens. Some invisible field, filling all of space, gently rotating light as it passes through, would mean the universe breaks a symmetry we long thought was completely ironclad. A deep rule about how physics is supposed to treat things even-handedly, left and right, forward and mirror image. And the prime suspect for that invisible field is a ghostly kind of particle that might turn out to be the dark matter, or the dark energy we have been chasing in the dark for decades, finally leaving a fingerprint we can read. It is not confirmed. The twist is small, and small twists are exactly where careful measurements tend to go wrong. It sits right on the edge of what we are allowed to trust. And so new telescopes are being built specifically to catch this rotation cleanly, to prove it real or make it disappear. But if it is real, then even the oldest light in the universe, the very first thing that ever traveled freely across space, arrives at your eyes carrying a small, quiet signature that the fundamental rules of reality bend. Number 10. The ghost that shouldn't have any mass. Everything so far has been a maybe, a signal we cannot confirm, a number that softened when we looked harder. This one is not a maybe. This one is proven, settled, published, and it is happening inside your body right now. There is a particle called the neutrino. It barely exists. It has almost no mass, no electric charge, and it ignores ordinary matter almost completely. Trillions of them, pouring out of the sun, are passing through you every single second. Something like 100 trillion of them, every second, streaming through your eyes, your bones, the chair beneath you, and the entire planet underneath that, as if none of it were solid at all. In your whole life, only a tiny handful will ever actually bump into a single atom of you. For a long time, the rulebook of particle physics, the standard model, said something very clear about neutrinos. It said they had to be completely massless, weightless, zero. That was not a guess. It was baked directly into the theory. Then scientists caught them doing something the rulebook forbade. Neutrinos come in 3 types, and as they travel, they change. A neutrino that leaves the sun as one type can arrive at Earth as another type entirely. They shift identity in flight, mid-journey, like a coin flipping over and over while it is thrown. And that shape-shifting can only happen if neutrinos have mass. Not zero. Something, however tiny. Which means the rulebook was wrong. Flatly, provably, undeniably wrong. The discovery was so important it won a Nobel Prize, and it forced physicists to reach in and rewrite the theory of everything, because reality had just handed them a particle that broke it in plain sight. And we still do not understand the fix. We do not know how neutrinos get their mass, when nothing in the original rules allowed for any. We do not know if a neutrino is secretly its own antiparticle, which would be its own kind of bombshell. We do not even know which of the 3 types is the heaviest. There are giant experiments running underground right now just to answer that last question. So the one fully confirmed crack in the deepest theory we have is not out in some distant galaxy where you will never go. It is a silent flood of ghost particles pouring through your chest as you listen to this. Every single one a tiny piece of proof that the rules are incomplete. Number 11, the free speed spacecraft kept stealing. When we send a probe out to the far reaches of the solar system, we often swing it past Earth first, letting the planet's gravity fling it faster and further on its way. A slingshot. And we track those slingshots with absurd precision, measuring the spacecraft's speed down to fractions of a millimeter per second. We know exactly how fast it should be going when it whips back around and heads off into deep space. And a few times, it wasn't. The spacecraft came out of the slingshot going very slightly too fast. A tiny unexplained boost, a few millimeters per second of free speed that simply should not exist. It happened to a probe called Galileo on its way to Jupiter back in 1990. It happened, biggest of all, to a probe called NEAR, which came out running about 13 millimeters per second too fast. It happened again to Rosetta. Each time, the craft stole a small sip of speed from nowhere, and the math could not say where it came from. So people threw everything they had at it, leftover tugs from Earth's ocean tides, a faint whisper of the upper atmosphere, a hidden halo of dark matter wrapped invisibly around the planet, even tiny tweaks to the laws of gravity themselves. None of it stuck. None of it explained the numbers. The little boost just sat there, measured, repeatable, and stubbornly unexplained. And then something almost eerier happened than the boost itself. It stopped. Later flybys tracked just as carefully as the earlier ones showed nothing, no extra speed, no anomaly at all. Juno swung past Earth in 2013, and it came out clean. The effect that had shown up again and again and again simply quit appearing right around the time we got much better at modeling exactly how our own tracking stations behave. So the leading suspicion now is that it was never the universe at all. It was probably us. Some subtle error in how we were watching that we slowly ironed out without ever quite catching it red-handed. Probably. But notice, it was never actually solved. It was measured, chased for years, and then it ghosted us before we could pin it down and name it. And a crack that appears, refuses to explain itself, and then vanishes the moment you get close, is its own deeply uncomfortable kind of mystery. Number 12. The sun too weak for you to be here. The sun has been slowly brightening for its entire life. That is just how stars work as they age, which means billions of years ago the young sun was noticeably dimmer than the one you see today. Not by a little. Somewhere around a quarter to a third weaker, a fainter, cooler star hanging in the sky of the early Earth. Now, do the simple math on that. A sun that weak, shining down on the early Earth, should have left the entire planet frozen solid. A ball of ice, all the way through, for its first couple of billion years. No liquid water anywhere on the surface, nothing to swim in, nothing for anything to begin in. Except that is not what the rocks tell us. The rocks say there were oceans, liquid water running across the surface of the early Earth back when the sun was far too weak to allow it. And in that water, life got started, almost embarrassingly early, within the first billion years or so. The planet should have been a frozen rock, and instead it was warm and wet and already alive. So what kept it warm? The leading answer is a much thicker blanket, enormous amounts of greenhouse gases packed into that early air. Carbon dioxide and methane, some of it possibly pumped out by the very first microbes as they fed, trapping the weak sunlight and holding onto the heat. A young Earth wrapped in a far heavier atmosphere than anything we have today, staying liquid on borrowed warmth. But the details refuse to fully close. The ancient rocks themselves put hard limits on how much of those gases could actually have been in the air, and when you run the numbers, they get uncomfortably tight. Something threaded a very narrow needle to keep this one planet from freezing over for more than 1 billion years straight. And notice what this particular broken number actually is. It is not some cold, distant object out past the edge of anything. It is the reason you exist. A dim young star, a planet that had no business staying warm, and a warmth we still cannot fully account for. Break that number, tip it just a little the wrong way, and there is no ocean, no first living cell, and no you here to wonder about it. Number 13. The universe that was too smooth. The universe is lumpy. Matter is not spread out evenly across it. It is clumped into galaxies and clusters of galaxies and long, stringy filaments with vast, dark, empty gaps yawning between them. And here is the remarkable part. We can actually predict how lumpy the universe should be. You take the ancient light of the Big Bang, you measure the incredibly faint ripples frozen into it, you run the clock forward billions of years, and out comes a clean prediction. This is exactly how clumpy the modern universe ought to be by now. Then you go and measure the real thing. You look at how the light from distant galaxies gets subtly bent and warped by all the matter it passes on. It's long way to us, and that bending quietly maps out where all the clumps of matter are. And for years, the answer kept coming back off. The real universe looked smoother than the prediction, less lumpy than it was supposed to be, as if structure had not grown quite as much as the theory demanded it should. And for a while, this looked like another genuine crack in the foundation, a companion to those other big disagreements, a sign that maybe our whole model of how the universe grows up from a smooth start into a lumpy present was missing something important. People got excited in that nervous, careful way physicists get when the numbers stubbornly refuse to line up. And then, over the last couple of years, it healed. Better surveys, more careful analysis, a much harder look at the messy, complicated details like the way exploding stars and feeding black holes violently shove gas around across whole galaxies in ways that can quietly fake out the measurement. And as the data got sharper and the messiness got handled, the gap shrank. And shrank. Until the smoothness the universe actually has and the smoothness the theory predicts basically reached out and shook hands. So this one, it turns out, was not reality breaking at all. This one was us, measuring slightly wrong and mistaking our own blurry vision for a broken cosmos. And that is worth sitting with, right here near the end. Because some of these anomalies are the universe being genuinely, deeply strange. And some of them are just us, standing in the dark, misreading what we see. The truly hard part is that from the inside, the two feel exactly the same. Number 14. The glitch that let you exist. Here is the deepest broken thing of all. And it is not out at the far edge of the universe. It is the reason there is a universe with anything at all inside it. Go back to the very beginning, the first sliver of a second. The Big Bang made matter. But by every rule we have, it should have made antimatter too in exactly equal amounts. Matter and antimatter are mirror twins. And when a twin meets its opposite, they destroy each other completely, both of them vanishing in a single flash of pure light. Equal amounts of each means total, perfect annihilation. Every particle finding its opposite, canceling out, leaving behind nothing but a universe flooded with light and no substance whatsoever. No galaxies, no planets, no you. That is exactly what should have happened. A perfectly balanced Big Bang quietly erases itself and leaves an empty, glowing nothing. But it didn't. For reasons that nobody has ever been able to explain, the balance was off by the tiniest imaginable sliver. For every billion particles of antimatter, there were 1,000,000,001 particles of matter, just one extra out of every billion. So when the great annihilation swept through and the mirror twins wiped each other out of existence, a thin residue was left standing. One lonely survivor for every billion pairs that destroyed themselves. That leftover residue is everything. Every star in the sky, every planet, every atom in your hands, in your eyes, in the air moving through your lungs. All of it is built from that 1 in a billion surplus. You are made of the ashes of a war that very nearly ended in a perfect draw. And here is the open wound in physics. Our rulebook does contain a few ways to tip that balance, to make a little more matter than antimatter. It just does not contain nearly enough of them. The tiny imbalances we can actually measure fall short of explaining you by an enormous margin, so the single most important fact about all of reality, that there is something here instead of nothing, has no accepted explanation. We honestly do not know why the universe did not simply cancel itself out and vanish. You are the glitch. The surplus. The rounding error in an equation that was supposed to come out to a clean, empty zero. The universe never promised to make sense. It only ever promised to be here. And against every reason it never should have been, so did you.